All right, in this lesson, we're going to have several steps to accomplish our goal, which is to add and subtract rational expressions, and we're going to have to find the least common denominator. So let's review what it's like to add, suppose, 3/4 plus 4/7. Now, depending on what kinds of denominators they are, we kind of go through different process for getting the least common denominator. And we will look at a particular process when ours are polynomial factors. But the least common denominator here is 28. Now, you may not be used to writing your problems in lines like this, but I highly recommend it for the algebraic fractions that we're headed into. Now, once you've gotten your common denominator, you're going to look at the old denominator and compare it to the new one and say, what was 4 multiplied by to turn it into 28? The answer is 7. So multiply the top by 7 also, and in this case, you get 21. Then go to this one and say, what was 7 multiplied by to get 28? The answer is 4. So multiply the top by 4, and we get 16. Now we have a problem that is very much like the kind we just finished in the previous lesson. I have a common denominator of 28, and I have 21 plus 16. I add those together for 37 over 28. I simplify, I reduce if I can. So we're going to do all these steps, but our numerators and denominators are going to be polynomials. So let's go ahead and jump in. All right, this has monomial denominators. So it's very much like what we were doing. What will 2z and 7z both go into? Well, it's going to need a z, but we will need 14 because they both go into 14z. Now let's do the comparison. The old denominator has changed into 14z. What would you have to multiply 2z by to turn it into 14z? And the answer is 7. So do the same thing to the top. 4 times 7 is 28. Now compare. What would you have to multiply 7z by to get 14z? The answer is 2. So multiply the top by 2. 2 times 49 is 98. I like to take a step to write the single denominator, and 28 plus 98. Most people just go ahead and do that step in their head. That's going to give me 126 over 14z. And then finally, I want to see if I can reduce that. And I think that maybe 14 goes into 126, and it does. 14 goes into itself once. 14 goes into 126 9 times. That gives me 9 over z. So the difference between this problem and the last section is I had to get a common denominator, and when I change the denominator, I must also change the top so that these are equivalent to the originals. Add or subtract the top, whatever the symbol says. With that new one, see if you can then reduce. Okay, we're going to do that several times with lots of different kinds of problems. All right, what will b and 4 both go into? They'll go into 4 times b. What do you have to multiply b by to get 4b? The answer is 4. So multiply the top by 4. 4 times 16a is 64a. Second fraction. What do you have to multiply 4 by to get 4b? The answer is b. So multiply the top, 3b, times b gives me 3b squared. All right, I have 4b, and I have 64a minus 3b squared. I can't really add or subtract anything up there because they're not like terms. So when you get to this point, you always say, can I factor? Can I reduce? I can't factor this. I can't do anything down here, so I'm done. It's tempting to deal with the 4 and the 64, but remember, 64 is not a factor of the whole numerator. It is a term within the numerator. That plus or minus keeps you from being able to do that. If you had a greatest common factor out there, then you could reduce. So this is our answer. Now let's talk a little bit more about that common denominator. When you just have different denominators, completely different, sometimes you just multiply them together, and that's the common denominator. When you start looking at these and you say, well, I have an x here and I have a 4x squared, the LCD, here's what I like to say. It is one of every different kind of factor, the highest power. So you have an x, you have a 4, and then you have an x squared. So you're going to need a 4, and you're going to need an x, but you're going to take the high power, you're going to take the x squared. So the common denominator is 4x squared. Now do the comparison. What do you have to multiply x by to get 4x squared? You'd need a 4 and an x. So multiply the top by, that happens to me more often than there we go. I'm going to multiply 6 times 4x, and that gets me 24x. Now compare. What do you have to multiply 4x squared by to get 4x squared? Well, 1. Or you could say nothing. So no change for that. It stays a 7. Write down your common denominator. And you have 24x plus 7. Can you factor the top? The answer is no. And since you can't factor the top, there's no reducing. It's done. Those parentheses are optional. I put them on there to emphasize that you can't reach in there and divide out from a term. All right, let's look at number 4. The denominators are getting to be more complicated polynomials. That does not necessarily make it harder. All right, the first one has an x plus 2. The second one, we need to factor it. There is a common factor of 7, so it's 7 times x plus 2. To get my common denominator, I have to be looking at the denominators in factored form. Now, in my previous examples, I didn't need to do any factoring. If you look at those denominators, there's no factoring to do. But this one is a binomial that can be factored. So the least common denominator, if you remember what I said, the least common denominator, one of every different kind of factor. Well, I see the monomial factor of a 7. I see the binomial of an x plus 2. I don't have any x plus 2 squareds, so my common denominator does not need an x plus 2 squared. So I have 7 times x plus 2, 7 times x plus 2. Compare. What do you have to multiply x plus 2 by? To get 7 times x plus 2, I think it's pretty obvious that you need to multiply it by 7. So do the same thing to the top. 7 times 3 is 21. This denominator, there's no change. So there's no change here. My least common denominator is 7 times x plus 2, and I have 21 plus 28. That gives me 49 over 7 times x plus 2. This is a monomial, and this is a factor of the denominator. I can divide that. That 7 is a factor. It's not inside the parentheses. 7 goes in there once, 7 goes in there 7 times. My answer is 7 over x plus 2. You can leave the x plus 2 in parentheses, or you can drop those parentheses off. All right. I have 7 over x plus 6, and I have x squared minus 36. That's the difference of squares. That factors into x plus 6 times x minus 6. The LCD, I need one of every different kind of factor. So I need an x plus 6, and I need an x minus 6. So I write it down twice, and then I compare. What do I have to multiply x plus 6 by to get this? In other words, what's the new factor down here? The new factor is x minus 6. So I'm going to multiply 7 times x minus 6. So whatever is new down here, multiply it times the top also. Compare here, no change. So the numerator, no change. So what do we have? Denominator, x plus 6 times x minus 6, and I have 7 parentheses, x minus 6 minus 6x. In this problem, and in some problems to come up, we're going to have to simplify on the top, and by this kind of simplifying is distributive property, combining like terms. Distributive property, 7 times x is 7x, 7 times negative 6 is negative 42, minus 6x, all over x plus 6, x minus 6. Now, I've got some like terms to combine. I have positive 7x and negative 6x. I subtract for x, and I have a minus 42, and it is over x plus 6 times x minus 6. And I cannot factor that, so I'm done. And that's my answer. All right. Let's look at number 6. My poor screen is just jumping around tonight. It is tonight that I'm recording this video. All right, this is kind of a unique problem. I hope that when you see d minus 7 and 7 minus d, you might think, oh, they have a relationship. Those are opposites. And when you see that, pick the one that you don't like. And I'm not real crazy about 7 minus d. Change it to its opposite, d minus 7. But when you do that, change the sign on top as well. Either that, or you can change the sign in front of the fraction. You can change one or the other. I have a common denominator already. So I have d minus 7, and I have 4 plus negative 9. That gives me negative 5 over d minus 7. There's no factoring I can do. It's done. So when you see things that look like opposites, you can change one of them if you change the numerator or change the sign out in front of the fraction also. Let's look at number 7. All right, this denominator is the difference of squares. I can factor it into x plus 1 times x minus 1. This denominator, it is a perfect square trinomial. If you don't recognize that, you would factor it into x minus 1 times x minus 1, but it's very helpful to recognize that that is x minus 1 squared. The reason being, remember what I said about the LCD. Take one of every different kind of factor that's up there, take the highest power. So I don't need to see this anymore. I don't need to see that anymore. I don't even need to see that anymore. All right, my common denominator. I need an x plus 1 because I have one there. I need an x minus 1. I have one in two places. Why do I need it squared? Because it is squared in one of the two denominators. One of each different kind, highest power. So x plus 1 times x minus 1 squared, x plus 1, x minus 1 squared. Do your comparison. What's new down here? Well, they both have x plus 1s, they both have x minus 1s, but this one has it squared. So you need an additional x minus 1. Multiply it times the top. X times x minus 1. You're looking at what exists in the old denominator. You're comparing it to what's in the new common denominator. Whatever the new factor is, you multiply it times the top. In this one, there's an x minus 1 squared. Here's an x minus 1 squared, but what's new is x plus 1. So I need to multiply 6 times x plus 1. All right. So I have x plus 1 times x minus 1, quantity squared. I have x times x minus 1. I have a minus sign, 6 times x plus 1. I have a couple of cases of the distributive property. Distribute here. X times x is x squared. X times negative 1 is negative x. Be super careful here. You're distributing a negative 6. Negative 6 times x is negative 6x. Negative 6 times 1 is negative 6. And it's still over x plus 1 times x minus 1 squared. Combine these like terms. I have x squared, that's minus 1, minus 6 gives me minus 7x, minus 6 over x plus 1, x minus 1 squared. You might spend a little time trying to factor this, but because of the signs, you're not going to be able to get factors of 6 that have a difference of 7. So you can't do anything to factor it, you can't do anything to reduce it. So many steps. Factor the denominators, create the least common denominator, put it in both of them, find out the new factor, put it all together over one denominator, multiply if you need to, combine like terms if you need to, check to see if you can factor. Okay, I think we have one more. All right, the first denominator can be factored. If I factor that, it's x plus 2 times x plus 2. And when I see that, I need to think that is x plus 2 quantity squared. This one is simply an x plus 2. What will my LCD be? Well, I need an x plus 2 because I have it in both, but I need it squared because I have to have the high power. So I have x plus 2 quantity squared. Let's compare. There's no change, so there's no change. It stays 17. Here, X plus 2 was multiplied by another x plus 2 to get squared, so we'll multiply 2 times x plus 2. I have a single denominator of x plus 2 squared, and I have 17 plus 2 parentheses x plus 2. That's 17 plus, let's use the distributive property, 2x plus 4 over x plus 2 squared. Combining the two constants, I keep the 2x. 17 and 4 is 21 over x plus 2 squared. Can I factor the numerator? No. So I can't reduce anything, and I'm done. There are a lot of steps involved in these. So you might have to go back and maybe pause the video and make sure that you understand each one of them, and then you work on your problems.